Since the dawn of time, humanity has been captivated by the mysteries above, always wondering what secrets the universe holds. For generations, our only tools were our eyes and rudimentary telescopes. But now, the James Webb Space Telescope has changed everything. This remarkable observatory is our golden window to the cosmos, revealing the universe with unprecedented clarity. It peers back billions of years, capturing the birth of the first stars and galaxies, and it can dissect the atmospheres of far-off worlds. More than just a machine, JWST stands as a testament to our relentless curiosity and desire to explore. We launched it 1,000,000 miles from home, unfolded its massive mirror, and pointed it toward the most mysterious regions of the universe. Our mission: to discover a planet in the Goldilocks zone. Not too hot, not too cold, but just right for life. That quest brought us to Proxima Centauri, the closest star to our solar system. Proxima Centauri is a faint, cool red dwarf, only 4 light-years away. Orbiting it is Proxima B, a planet that has captured our imagination since its discovery. With JWST, we can study the light from Proxima B's atmosphere, searching for water, methane, and other potential signs of life. Every photon it gathers carries a message from the far reaches of space. Years of preparation led scientists to focus on Proxima B as the ideal candidate in our search for another Earth. We hoped to uncover traces of water or a shield of atmosphere, but what we discovered surpassed all expectations. The universe, it turned out, had a shocking revelation in store. JWST is more than a camera or a time machine. It's our most powerful tool for unraveling cosmic mysteries. With each new discovery, we inch closer to understanding our place in the vast expanse. And sometimes, the universe's answers are more bizarre than we ever dreamed. The hunt for life is only beginning, and the cosmos is finally ready to respond. Proxima B is special because it's close, just 4 light-years away, our cosmic backyard. If we ever visit another star, Proxima Centauri will be our first stop. Proxima B orbits a red dwarf, much smaller and cooler than our Sun. To stay warm, it orbits very close, completing a year in just 11 Earth days. This puts it in the habitable zone, where liquid water could exist. Where there's water, there could be life. But red dwarfs are volatile, shooting out powerful flares that could strip away a planet's atmosphere. Some scientists imagined Proxima B as a blue water world. Others saw a barren, scorched rock. We needed a better look. Enter the James Webb Space Telescope. The mission point JWST at Proxima B let it stare for hours and analyze the starlight filtering through its atmosphere. This would reveal what kind of world Proxima B truly is. Is it dead, or is it alive? The scientific community buzzed with anticipation. Data from Proxima B would be a breakthrough, no matter what it showed. But what came back was stranger than any theory. The world held its breath as the first results arrived. JWST was about to change everything we thought we knew. The search for life had become a search for understanding. And Proxima B was at the center of it all. The next chapter in our cosmic story was about to begin. We were ready for answers, but the universe had other plans. The signal from Proxima B was about to shock the world. July 10th, 2025. The day began like any other at the Space Telescope Science Institute. Teams gathered, watching as raw data from JWST arrived after its 1,000,000-mile journey. The first readings brought excitement. Proxima B had an atmosphere. This alone was historic. A planet orbiting a volatile red dwarf could hold on to its air. Cheers erupted, but as more data came in, the mood shifted. A strange, regular pattern appeared in the atmospheric data. It wasn't a natural chemical signature or an instrument error. The signal was real, embedded in the light from Proxima B's atmosphere. A junior analyst noticed the perfect regularity. The room fell silent. The pattern repeated every few minutes with mathematical precision. It was not random noise, nor any known natural phenomenon. Dr. Eris Thorne, the lead astrophysicist, stared at the screen, stunned. He had spent his life searching for signs of life, but this was something else. The universe wasn't whispering, it was shouting. The signal was complex, structured, and impossible to ignore. The team checked everything, again and again. The signal persisted. It was a message, but not in any language we knew. The discovery was overwhelming. Humanity had never seen anything like it. The search for life had found something far more profound. The world was about to change. The universe had spoken, and we were listening. The next step was to understand what we had found, and the implications were staggering. The signal was terrifying, a planetary-scale pulse of industrial gases. The entire atmosphere of Proxima B was changing in a rhythmic, coordinated way. Complex chlorofluorocarbons, CFCs, were rising and falling in a perfect, steady rhythm. These are artificial molecules, created by industry, not nature. It was as if the planet was breathing pollution. The presence of CFCs was a near certain sign of technology. Finding them was like discovering a plastic bottle on a deserted island. Someone was there. But the pulse itself was even more unsettling. The entire atmosphere changed in unison, suggesting a level of technology and coordination beyond anything on Earth. This wasn't a few factories. It was a global system, operating like a single machine. Was it terraforming, energy generation, or something else? The data gave no answers, only more questions. Imagine seeing all the lights on Earth turn on and off together, every minute. This was a technological scream across the stars. It was advanced, deliberate, and close. Our sense of cosmic safety was shattered. We were no longer alone, and the universe felt much smaller. The news broke quickly. JWST detects artificial signal from Proxima B. The world reacted with awe, excitement, and fear. For the first time, humanity faced the real possibility that we are not alone. People gathered in public squares, watching scientists try to explain the unexplainable. At first, many thought it was a hoax, but expert confirmation made the reality sink in. The world held its breath, united by a single question. Who is on Proxima B? Governments scrambled, emergency meetings were held, and military leaders were briefed. Was this a threat or a peaceful signal? No one knew. The signal wasn't a message, just a display of technological power. We were like ants, staring at a giant footprint. For a moment, our own conflicts seemed small. The mystery of Proxima B became humanity's mystery. The fear was real, but so was the wonder. We stood on the edge of a new era, looking at a star that was now a destination. The universe had changed, and so had we. Our place in the cosmos would never be the same. Theories flooded in. What was causing the pulse of industrial gas? Some hoped it was a massive terraforming project, a sign of planetary engineering. Others feared it was the exhaust of a planet-wide energy system, the work of a civilization far beyond our own. Some wondered if the pulse was a warning, a technological keep-out sign. Maybe they knew we were watching, and this was a show of strength. The darkest theory. We were witnessing a dying planet, the last gasps of a civilization collapsing under its own pollution. The signal became a mirror, reflecting our hopes and fears. Was it a beacon of progress, a warning, or a tragedy? The truth remained out of reach. The only certainty, we were not alone. The universe had given us a mystery, and it was up to us to solve it. The search for answers had just begun. The Proxima B signal changed everything for space agencies worldwide. JWST was retasked to focus on Proxima B, searching for more clues. Every major radio telescope on Earth turned toward Proxima Centauri, listening for any sign of communication. Scientists and engineers began designing new missions, including probes to visit the system. Projects like Breakthrough Starshot received new funding and urgency. The goal to see Proxima B with our own eyes, even if it took decades. Meanwhile, a new field, Proxima Studies, emerged, uniting experts from every discipline. How should we respond if we receive a message? What would contact mean for humanity? The signal had opened a Pandora's box of questions. The next steps were about more than science. They were about our future. We were no longer just observers. We were preparing to meet our neighbors. The journey had truly begun. The discovery on Proxima B changed our perspective forever. We now live in the age of knowing we are not alone. The universe is a neighborhood, and someone is home next door. This knowledge is thrilling and humbling. Our conflicts seem smaller. We are one human family on a fragile planet. Perhaps this is the wake-up call we needed, to work together and reach for the stars. The future is uncertain, but filled with possibility. Will we receive a message? Will we meet our cosmic neighbors? Whatever happens, we cannot go back. Every time we look up, we'll think of Proxima B. The universe is more complex and populated than we imagined. Our fear is turning into curiosity. We are explorers by nature. The signal from Proxima B is an invitation to a larger story. Humanity is ready to turn the page and begin the next chapter.